The Mississippi River cuts through Rock Island like a steel blade through autumn fog, and on this October morning in 1941, the sound of hammers on metal echoes across Arsenal Island with the rhythm of war drums. Inside Building 300 at Rock Island Arsenal, Illinois, Margaret Kowalski wipes the sweat from her brow and adjusts the massive steel barrel of the 105mm howitzer M2A1 she's been assembling for the past 6 hours. The gun weighs 4,980 pounds when complete, but right now it's just components scattered across her workstation like the bones of some mechanical beast waiting for resurrection. The barrel alone stretches 7 feet 7 inches, its bore precisely machined to 4.13 inches 105 millimeters in the metric system that America's enemies prefer. Margaret doesn't think about metrics. She thinks about the $25,000 price tag attached to each howitzer that rolls off this production line, and how that sum could buy 3 modernized 75mm field guns and still have change left over. But the War Department has decided that the M2A1 105mm howitzer will become the backbone of American divisional artillery, replacing the obsolete French 75mm guns that have served since the Great War. Every American infantry division will carry 36 of these weapons, 3 battalions of 12 guns each, 1 battalion supporting each of the division's 3 infantry regiments. The mathematics are staggering. If America fields 100 divisions, they'll need 3,600 howitzers. If they fight on multiple fronts simultaneously, the number doubles, then triples. Margaret doesn't know these numbers. She knows that yesterday she completed howitzer number 597 for the year 1941, and that her supervisor, Thomas Chun, has told her that next year's production target is 3,325 units. She knows that the equilibrator assembly she's installing links the axle area to the rear of the cradle, allowing this gun to fire at high elevations without requiring a pit to be dug for recoil absorption. She knows that the recuperator cylinder mounted above the barrel contains compressed air and hydraulic fluid heated to 55 degrees Celsius, designed to return the gun to firing position after each shot. What Margaret doesn't know, as she torques the final bolt on the trunnion mounting, is that this particular howitzer serial number U.S. Army 598 will fire its first combat round on a beach in North Africa 11 months from now, and its last round on a hill overlooking the Elbe River in Germany 3.5 years later. She doesn't know that it will fire 2,417 high-explosive shells, 63 smoke rounds, 28 illumination rounds, and 14 white phosphorus rounds before the war ends. She doesn't know that the crew of 8 men who will operate this weapon will give it the nickname Margaret's Monster in her honor, painted in white letters beneath the gun shield. But she knows her work matters. Every component must meet specifications precise to thousandths of an inch. The horizontal sliding breech block must seal perfectly to contain chamber pressures exceeding 15,000 pounds per square inch. The split trail carriage must absorb recoil forces that would shatter lesser mechanisms. The gun shield, designed to deflect shrapnel and small arms fire, must be angled precisely to protect the crew without interfering with gun elevation or traverse. 3 workstations over, James Harrison is completing the final calibration on another M2A1's recoil mechanism. The hydropneumatic system requires precise fluid pressures and air volumes to function correctly through 10,000 rounds of firing, the expected service life of each barrel. Harrison served as an artilleryman in France during the Great War, operating the French 75mm guns that these new howitzers will replace. He understands the difference between the flat trajectory of the old guns and the high-angle plunging fire capability of these howitzers. The 75mm gun could reach 8,000 meters with direct fire, but its shells struck targets at shallow angles, limiting effectiveness against entrenched positions. The M2A1 howitzer sacrifices some range 11,270 meters maximum but delivers its 33-pound high-explosive shells in steep arcs that can reach targets behind hills, in defile, and in prepared defensive positions. The larger caliber allows a significantly greater bursting charge. Where the 75mm shell carried 455 grams of explosive, the 105mm shell delivers over twice that amount. Harrison knows that range isn't everything in artillery. Accuracy matters more. The M2A1, firing an HE-M1 shell at 9,000 meters, achieves a probable error in range of 41 meters and a probable error in line of 10 meters. half of all shells will land within those error circles around the target point. For divisional artillery supporting infantry attacks, this precision makes the difference between suppressing enemy positions and providing ineffective harassment fire. As 1941 ends and 1942 begins, Rock Island Arsenal shifts into wartime production. The attack on Pearl Harbor on December 7 transforms the United States from reluctant observer to active participant in a global conflict. Production targets for the M2A1 Howitzer triple overnight. Margaret Kowalski finds herself working 12-hour shifts, 6 days a week. The workforce at Rock Island Arsenal swells from 6,000 to 12,000 workers, many of them women replacing men who have joined the armed forces. The production line becomes a symphony of industrial precision. In Building 210, massive hydraulic presses forge gun barrels from high-grade steel billets. Each barrel begins as a solid cylinder of steel weighing 3,000 pounds. Steam-powered boring machines hollow out the interior to precise tolerances, creating rifling grooves that will impart spin to projectiles for accuracy and stability. The rifling consists of 32 grooves, each twisted one turn in 20 calibers, one complete rotation every 21 feet. Quality Control Inspector Patricia Liu examines each barrel with instruments precise to thousandths of an inch. Bore diameter must measure exactly 4.13 inches. Rifling depth must be consistent within tolerances that would challenge a watchmaker. Chamber dimensions must match ammunition specifications exactly, or the gun will fail to fire or worse, explode during operation. Liu rejects any barrel showing the slightest deviation from specifications. Rejected barrels return to the foundry for remelting and reforging. In Building 300, where Margaret assembles complete howitzers, the pace quickens as 1942 progresses. By March, the production line completes 8 howitzers per day. By June, 12 per day. By September, 15 per day. Each howitzer requires 3 weeks from initial components to final inspection. The trail legs, forged from high-tensile steel, must withstand the enormous forces generated during firing. The shield, rolled from armor plate, must stop rifle bullets and shrapnel fragments while weighing no more than necessary for transport. The M2A1's weight of 4,980 pounds makes it heavy for its caliber, but this reflects deliberate design philosophy. Army Ordnance Engineers, studying captured German artillery from the Great War, chose durability over weight savings. The gun is built to fire thousands of rounds without barrel replacement, to survive transport over rough terrain, and to function reliably under combat conditions where maintenance facilities are limited. This design philosophy contrasts sharply with approaches taken by other nations. In factories scattered across the Greater German Reich, engineers at Rheinmetall and Krupp are completing production of their own 105mm howitzer, the 10.5 cm light Feldhaubitz 18, or Luftwaffe 18. The German gun weighs only 1,985 kilograms, nearly a full ton lighter than the American M2A1. The weight difference reflects different tactical priorities. German doctrine in 1942 emphasizes rapid maneuver warfare, requiring artillery that can be moved quickly by horse teams or light tractors. The Luftwaffe 18 achieves this mobility through careful weight reduction in every component. The barrel, while shorter than the M2A1's, still delivers effective fire to 10,675 meters. The carriage, mounted on steel wheels with pneumatic tires, can be towed at speeds up to 50 kilometers per hour on good roads. But the German gun's light construction exacts a price in durability. Where the M2A1 barrel is rated for 10,000 rounds, the Luftwaffe 18 requires replacement after 6,000 rounds. The lighter carriage, while easier to transport, shows wear more quickly under the stresses of combat firing. German artillery units in Russia during 1941 and 1942 lose significant numbers of Luftwaffe 18 howitzers not to enemy action, but to mechanical failure during the spring thaw, when the guns prove too heavy for their light carriages to be extracted from mud by available prime movers. At the Krupp factory in Essen, production supervisor Heinrich Müller reviews the daily output reports with growing concern. His facility completed 1,200 Luftwaffe 18 howitzers during 1941, but raw material shortages are constraining production for 1942. Steel allocations have been reduced by 15%. Copper for the recuperator systems is increasingly scarce as the metal is diverted to ammunition production and electrical systems for U-boats and aircraft. Muller's workforce, like Margaret Kowalski's at Rock Island Arsenal, includes increasing numbers of women and foreign workers prisoners of war, conscripted laborers from occupied territories, and volunteers seeking better rations and working conditions than available in their home countries. Quality control becomes an increasing challenge as experienced German craftsmen are drafted for military service and replaced by workers with minimal training and, in some cases, little motivation to produce weapons for the Wehrmacht. The contrast in production philosophy becomes apparent in the details. American M2A1 Howitzers receive serial numbers engraved deeply into the steel, allowing individual weapons to be tracked through their entire service lives. German Luftwaffe-18 Howitzers receive painted identification numbers that wear off during field service, making individual gun tracking nearly impossible. American quality control rejects any howitzer showing cosmetic flaws or minor dimensional variations. German quality control, under pressure to meet production quotas, accepts weapons with visible flaws as long as basic functionality remains intact. By December 1942, these philosophical differences are producing measurable results. Rock Island Arsenal has delivered 3,325 M2A1 howitzers during the year, exceeding production targets despite the challenges of wartime expansion. Each gun meets specifications identical to peacetime standards. Ammunition compatibility between guns is perfect. Any M2A1 can fire ammunition produced for any other M2A1, regardless of production date or manufacturer. German artillery production faces increasing challenges. While Krupp and Rheinmetall together produce over 2,000 Luftwaffe-18 howitzers during 1942, quality variations between factories create ammunition compatibility problems. Shells produced for guns manufactured at one facility may not chamber properly in weapons from another facility. Spare parts from different manufacturers sometimes require hand fitting to achieve proper function. These problems reflect broader industrial challenges facing the German war economy. Unlike the United States, which can dedicate entire factories to single weapon systems and maintain consistent production standards, Germany must distribute production across multiple facilities to protect against bombing and maintain security. The resulting lack of standardization creates logistical nightmares that will worsen as the war continues. Meanwhile, in the Pacific Theater, Japanese factories are producing their own interpretation of the 105mm howitzer. The Type 91 10cm howitzer represents yet another approach to the same tactical requirement. Designed by the French Schneider Company in the late 1920s, but modified extensively by Japanese engineers, the Type 91 weighs only 1,500 kilograms, half the weight of the American M2A1. At the Osaka Arsenal, production supervisor Hiroshi Yamamoto oversees manufacture of Type 91 howitzers with the same attention to precision that characterizes Japanese industry. Each gun receives hand fitting of critical components to achieve tolerances that exceed those of mass-produced weapons. The result is a howitzer of exceptional accuracy and reliability, but production numbers remain limited by the time-intensive manufacturing process. The Type 91's light weight reflects Japanese tactical requirements for operations in terrain where roads are limited and mechanical transport is scarce. The gun can be broken down into components light enough for pack animal transport, then reassembled quickly for firing. Maximum range of 10,500 meters provides adequate fire support for infantry operations, while the 15-kilogram high-explosive shell delivers sufficient destructive power against typical targets. Japanese ammunition production follows different priorities than American or German practice. Where American and German factories emphasize high-volume production of standard high-explosive shells, Japanese facilities produce smaller quantities of specialized ammunition types. The Type 91 can fire chemical shells, armor-piercing shells, shrapnel shells, and various experimental rounds developed for specific tactical situations. This diversity in ammunition types reflects Japanese tactical doctrine, which emphasizes careful preparation and precise application of firepower rather than overwhelming volumes of fire. Japanese artillery officers are trained to achieve maximum effect with minimum expenditure of ammunition, a philosophy driven partly by Japan's limited industrial capacity and partly by traditional military culture that values skill and economy over brute force. As 1943 begins, these different national approaches to artillery production are being tested in combat across multiple theaters. American M2A1 Howitzers are deployed with U.S. forces in North Africa, where Operation Torch has brought American divisions into contact with German and Italian forces. The guns prove their worth in the mountainous terrain of Tunisia, where their high-angle fire capability allows engagement of enemy positions hidden behind ridgelines. Captain Robert Martinez commands Battery A, 337th Field Artillery Battalion, supporting the 2nd Infantry Division near Kasserine Pass. His 4 M2A1 Howitzers occupy firing positions in a wadi 3 kilometers behind the forward infantry positions, their crews protected by sandbagged gun pits that provide cover from small arms fire and shell fragments. Martinez has been training with the M2A1 since 1941, when his National Guard unit was federalized and equipped with the new howitzers. He understands the weapon's capabilities and limitations intimately. Maximum range of 11,270 meters allows his battery to engage targets throughout the divisional front, but accuracy decreases at extreme ranges. For precision fires against point targets, Martinez prefers to engage at ranges between 6,000 and 8,000 meters, where the probable error in range drops to 25 meters and the probable error in line to 6 meters. The gun's semi-fixed ammunition system projectile and propelling charge loaded separately, but fired together allows precise adjustment of range and trajectory. 7 different propelling charges, designated Charge 1 through Charge 7, provide muzzle velocities from 473 meters per second to 650 meters per second. For long-range fires, Martinez uses Charge 7 to achieve maximum velocity and range. For close support fires where high trajectory is desired to clear friendly positions, he uses Charges 2 or 3 to achieve steep angles of fall. Each M2A1 in Martinez's battery can sustain a rate of fire of 3 rounds per minute indefinitely, or deliver burst fires of 10 rounds per minute for short periods. The gun's robust construction allows continuous firing at maximum rate for 10 minutes without overheating, though barrel life decreases if such intensive firing becomes routine. Martinez rations his ammunition carefully. Each gun receives a basic load of 100 rounds, with additional supplies arriving by truck convoy when tactical situation permits. The 33-pound high-explosive shell fired by the M2A1 contains approximately 3 pounds of composition B explosive, making it significantly more effective than the smaller shells fired by 75mm guns. Against personnel in the open, the bursting radius extends to 30 meters. Against light field fortifications, a single direct hit will usually destroy the position. Against heavy concrete bunkers, multiple hits are required, but the M2A1's accuracy makes such precision fires achievable. Martinez's battery fires its first combat missions on February 19, 1943, during the German offensive at Kasserine Pass. Forward observers with the advancing infantry request fires against German machine gun positions located on a ridgeline 800 meters to their front. The targets are invisible from the howitzer positions but clearly marked on detailed topographic maps prepared by military intelligence units. The fire mission requires precision. American infantry are positioned only 300 meters from the target area, leaving minimal margin for error. Martinez directs his guns to fire single rounds for adjustment, with each gun crew recording precise data for range, deflection, and charge. The first round impacts 100 meters over the target. Subsequent adjustments bring impacts within the target area, and Martinez orders fire for effect, all 4 guns firing 3 rounds each in rapid succession. 12 33-pound shells impact the German positions within 30 seconds, each detonating with the force of 3 pounds of high explosive. The machine gun fire ceases. American infantry report the positions destroyed and advance without further opposition. Total ammunition expenditure: 16 rounds. Total time from initial fire request to mission completion: 8 minutes. This engagement illustrates the tactical effectiveness that American artillery doctrine seeks to achieve. The M2A1's combination of range, accuracy, and destructive power allows small numbers of guns to provide decisive fire support for infantry operations. The gun's reliability ensures that it will fire when called upon. The standardized ammunition ensures that any M2A1 can fire any compatible round without compatibility problems. 300 kilometers to the east, German artillery units are discovering that their Luftwaffe-18 howitzers face different challenges in North African combat. The gun's lighter construction, advantageous in European campaigns where roads are numerous and supplies abundant, becomes problematic in desert warfare where mechanical stress and supply shortages test equipment durability. Hauptmann Klaus Weber commands the 2nd Battery, 155th Artillery Regiment, supporting the 10th Panzer Division near El Alamein. His 4 Luftwaffe-18 howitzers have been in continuous operation since arriving in North Africa 6 months earlier, and the desert environment is taking its toll on men and equipment alike. The Luftwaffe-18's pneumatic tires, essential for high-speed transport on European roads, prove vulnerable to desert conditions. Sharp rocks and extreme temperature variations cause frequent punctures and sidewall failures. Weber's battery carries extra tires and tire repair equipment, but each will change requires 2 hours of work by the entire gun crew, reducing the battery's availability for fire missions. More serious is the effect of sand infiltration on the gun's precision mechanisms. The Luftwaffe-18's recoil system, dependent on precise fluid seals and close tolerances, suffers from sand contamination that causes gradual degradation in performance. Weber's guns, which achieved accuracy comparable to American weapons when new, now show increasing dispersion as sand particles wear away metal surfaces and contaminate hydraulic fluids. Ammunition supply presents additional challenges. The Luftwaffe-18 fires 14.8 kilogram high-explosive shells containing approximately 2 kilograms of explosive less than the American 33-pound shells, but still effective against most targets. However, German ammunition production is increasingly constrained by raw material shortages and bombing of industrial facilities. Weber's battery receives irregular supplies of shells, sometimes going days without resupply while American forces receive consistent ammunition deliveries. The tactical implications become apparent during the Second Battle of El Alamein in October 1942. Weber's battery fires 843 rounds during the 5-day engagement, but ammunition shortages limit sustained fire missions. When British infantry attack positions defended by German forces, Weber cannot provide the continuous fire support that American batteries routinely deliver. Instead, German artillery fires in short, intense concentrations designed to maximize psychological effect while conserving ammunition. This ammunition conservation reflects broader constraints on German artillery operations. Where American batteries can fire preparatory bombardments lasting hours and involving thousands of rounds, German batteries must achieve similar effects with hundreds of rounds carefully distributed over time. German artillery officers become experts in terrain analysis and target prioritization, identifying the most critical enemy positions for engagement while ignoring less important targets that American artillery would suppress as routine. The difference in tactical philosophy reflects industrial capacity constraints that will worsen as the war continues. American industrial production, protected by oceans from enemy attack and supplied by resources from across the globe, can afford to emphasize volume over conservation. German production, increasingly constrained by material shortages and bombing damage, must prioritize efficiency and economy in all aspects of military operations. By the end of 1942, these constraints are forcing changes in German artillery tactics. The Wehrmacht's artillery doctrine, initially based on rapid concentration of fire from multiple batteries to achieve overwhelming local superiority, evolves toward harassment and interdiction fires designed to disrupt enemy operations while conserving ammunition for critical engagements. Meanwhile, in the Pacific Theater, Japanese artillery faces similar challenges but develops different solutions. The Type 91 howitzers' lightweight and precision manufacturing allow Japanese batteries to achieve tactical effects through accuracy rather than volume. Japanese artillery doctrine emphasizes careful observation and precise ranging to ensure first-round hits, reducing ammunition expenditure while maintaining effectiveness. Colonel Takashi Nakamura commands the 3rd Artillery Regiment supporting the 32nd Army on Okinawa. His regiment includes 12 Type 91 howitzers positioned in carefully prepared positions that take advantage of the island's terrain features for protection and concealment. Each gun position includes underground ammunition storage, overhead protection against air attack, and multiple firing positions to complicate enemy counter-battery efforts. Nakamura's guns opened fire on American landing forces on April 1, 1945, delivering precisely aimed rounds against landing craft and beach positions. The Type 91's 15-kilogram shells, while smaller than American 33-pound rounds, prove effective against personnel and light equipment. More importantly, the gun's concealed positions and disciplined firing procedures make them difficult for American counter-battery radar to locate and engage. Japanese artillery tactics emphasize fire discipline and target selection. Rather than engaging every target that presents itself, Japanese batteries wait for high-value targets that justify expenditure of scarce ammunition. When American tanks advance within range, Japanese guns engage with armor-piercing rounds. When American infantry concentrate for attacks, Japanese guns fire precisely timed concentrations designed to disrupt assault formations. The Type 91's accuracy allows such precise engagements. At ranges up to 6,000 meters, trained Japanese crews can achieve first-round hits against point targets. The gun's rifling imparts sufficient spin to projectiles to ensure consistent accuracy even at maximum range of 10,500 meters. This precision reduces ammunition expenditure while maintaining tactical effectiveness. However, Japanese artillery faces the same industrial constraints affecting German forces. Ammunition production cannot match consumption rates during intense combat. Steel shortages limit production of new barrels to replace those worn out by extended firing. Most critically, the complex manufacturing processes required for precision artillery production cannot be maintained under wartime conditions of bombing and material scarcity. As 1943 progresses into 1944, these industrial constraints begin to determine tactical outcomes more than weapon design characteristics. American forces, supplied by industrial capacity that produces 8,536 M2A1 Howitzers during the war, can afford tactical doctrines that emphasize overwhelming firepower and sustained support. German and Japanese forces, constrained by limited production and dwindling supplies, must adopt tactics that emphasize economy and precision. The statistical comparison becomes stark as the war reaches its climax. American artillery units routinely fire preparatory bombardments involving tens of thousands of rounds. The 2nd Infantry Division alone fires over 300,000 rounds from its M2A1 Howitzers between D-Day and VE Day. German artillery units, rationing their limited supplies, fire hundreds of rounds in similar periods. Japanese artillery units on isolated Pacific islands make each round count, firing dozens of carefully aimed shells where American units fire thousands. This disparity reflects not just industrial capacity but also strategic philosophy. American forces, confident in their ability to replace losses and resupply forward units, can afford to emphasize material superiority over tactical finesse. German and Japanese forces, increasingly outnumbered and undersupplied, must rely on superior training and tactics to achieve results that American forces obtain through superior firepower. The M2A1 howitzer becomes the symbol of American industrial might applied to military purposes. 1 out of every 5 shells fired by American forces during World War II is a 105mm high-explosive round fired from an M2A1. The gun equips 264 field artillery battalions, including 147 divisional battalions and 14 non-divisional battalions in the European theater, plus 62 divisional and 9 non-divisional battalions in the Pacific. Each howitzer requires 8 men for operation: gun commander, gunner, assistant gunner, loader, ammunition handlers, and support personnel. The 8,536 M2A1 howitzers produced during the war thus require approximately 68,000 trained artillery personnel for operation. Add support personnel: observers, communication specialists, ammunition handlers, maintenance crews, and command elements, and each M2A1 howitzer represents the training and equipment of 25 soldiers. This personnel requirement illustrates another advantage of American industrial capacity. The United States can afford to assign large numbers of highly trained specialists to operate complex weapons systems. German and Japanese forces, facing severe manpower shortages, must assign multi-role personnel who may operate artillery one day, infantry weapons the next, and support vehicles the day after. The training differences become apparent in combat effectiveness. American artillery crews, trained exclusively on M2A1 howitzers and supported by standardized procedures and equipment, achieve high levels of proficiency in all aspects of gun operation. German artillery crews, trained on multiple weapon systems and frequently transferred between different gun types, achieve competence but rarely the specialized expertise of American crews. At Rock Island Arsenal, production continues through 1944 despite increasing challenges. Raw material shortages require careful allocation of steel, copper, and other critical metals. Skilled workforce shortages require extensive training programs for new employees. Transportation bottlenecks delay delivery of completed howitzers to embarkation ports. Margaret Kowalski, now a shift supervisor overseeing 12 workers, has personally participated in assembly of over 800 M2A1 howitzers. She knows every component, every specification, every critical tolerance that determines whether a gun will function reliably in combat. Her expertise has been recognized with promotion to Quality Control Inspector, responsible for final verification of each completed howitzer before acceptance by Army Ordnance officers. The inspection process requires 3 days per gun. Every dimension must be verified against engineering drawings. Every mechanism must be tested through its complete range of operation. Test firing with live ammunition validates accuracy, range, and functioning under conditions that simulate combat use. Only howitzers that pass every test receive the acceptance stamp that authorizes shipment to combat units. Margaret's inspection station processes 4 completed howitzers per week. Her rejection rate remains below 2%, evidence of the high quality achieved by Rock Island Arsenal's production processes. Rejected howitzers return to the production line for repair or, if defects are severe, complete disassembly and rebuilding. No M2A1 howitzer leaves the arsenal with known defects. This quality control philosophy contrasts with practices at German and Japanese facilities, where production pressures force acceptance of weapons with minor defects that would cause rejection at American facilities. The long-term consequences become apparent as the war progresses and equipment reliability determines tactical effectiveness. By 1944, the cumulative effect of these production philosophies is reshaping the strategic balance. American forces field artillery units equipped with standardized, reliable weapons supported by abundant ammunition supplies. German forces field artillery units equipped with weapons of varying quality supported by irregular ammunition supplies. Japanese forces field artillery units equipped with high-quality weapons supported by critically limited ammunition supplies. The tactical implications ripple through every level of military operations. American infantry commanders plan operations knowing that artillery support will be available when requested, in the quantities requested, with the reliability expected. German and Japanese infantry commanders plan operations around artillery limitations, requesting only essential fires and developing backup plans for situations when artillery support is unavailable. The M2A1 howitzer becomes more than a weapon, it becomes a symbol of American military industrial capability. Each howitzer represents $25,000 of investment, 3 weeks of skilled labor, and the coordination of dozens of suppliers providing everything from high-grade steel to precision optical instruments. Multiply by 8,536 units produced, and the M2A1 program represents over $200 million of wartime investment equivalent to several billion dollars in contemporary currency. This investment pays dividends in combat effectiveness that extend far beyond the immediate tactical impact of the guns themselves. The confidence that comes from knowing that fire support will be available when needed allows American infantry to undertake operations that would be impossible without reliable artillery support. The psychological effect on enemy forces of facing consistent, accurate, overwhelming firepower influences tactical decisions and strategic planning. Field Marshal Erwin Rommel, commenting on American artillery effectiveness during the Italian campaign, observes, "The enemy's tremendous superiority in artillery and even more in the air has broken the front open during the Normandy campaign," he adds. Also in evidence is their great superiority in artillery and outstandingly large supply of ammunition. These observations reflect the cumulative impact of American artillery production. The M2A1 howitzer, produced in numbers that German and Japanese planners considered impossible, equipped American divisions with fire support capabilities that transformed tactical possibilities. Operations that German and Japanese forces could not attempt due to artillery limitations became routine for American forces equipped with M2A1 howitzers and abundant ammunition supplies. The production statistics tell the story of industrial transformation. Rock Island Arsenal's output of 597 M2A1 howitzers in 1941 increases to 3,325 in 1942, then to 2,684 in 1943. By 1944, when production reaches 1,200 units, the United States has already equipped its artillery units with sufficient howitzers to support global operations on multiple fronts simultaneously. The decline in production during 1944 and 1945 down to 730 units in 1945 reflects not reduced demand but the achievement of production goals. With 8,536 M2A1 howitzers produced by war's end, American artillery units have sufficient weapons for immediate needs plus reserves for replacement of combat losses and peacetime training requirements. This production achievement required fundamental changes in American industrial practice. Rock Island Arsenal expanded from 6,000 to 12,000 workers. Production lines that assembled 14 M1 howitzers in 1933 produced over 3,000 M2A1 howitzers in 1942. Quality control processes that accepted 1% defect rates for peacetime production achieved rejection rates below 2% for wartime production. The human cost of this achievement is measured in 12-hour shifts, 6-day weeks, and production schedules that left no time for equipment maintenance or worker rest. Margaret Kowalski and her colleagues worked through the war with intensity that would have been unsustainable in peacetime but was accepted as necessary for victory. The toll on health, families, and personal lives was enormous, but the alternative defeat by enemies whose industrial capacity could not match American production was unacceptable. The strategic implications extend beyond World War II. The M2A1 howitzer, redesignated M101A1 in 1962, continued in American service through the Korean War and Vietnam War. The gun's robust construction and reliable operation made it suitable for conflicts lasting decades rather than years. Many M2A1 howitzers produced during World War II remained in service through the 1980s, testimony to the quality of wartime production. International sales extended the weapon's service life even further. 67 countries eventually operated M2A1 howitzers, with some remaining in service through the early 21st century. The gun's design influenced artillery development in nations around the world, establishing design principles and manufacturing standards that shaped military production for generations. The contrast with Axis artillery becomes more apparent with historical perspective. German Luftwaffe-18 howitzers, produced in smaller numbers and with increasing quality problems, were largely replaced by 1945. Japanese Type 91 howitzers, manufactured in even smaller quantities, became extinct with Japan's defeat. Neither weapon achieved the production numbers or service longevity of the American M2A1. This differential reflects fundamental differences in strategic approach. American strategy emphasized overwhelming material superiority achieved through industrial production. German and Japanese strategies emphasized tactical and technical superiority achieved through superior training and innovative tactics. The war's outcome validated the American approach, demonstrating that industrial capacity could overcome tactical advantages if applied with sufficient scale and persistence. The M2A1 howitzer program illustrates broader principles of wartime production that influenced American military policy for decades. Investment in production capacity during peacetime provides capabilities that cannot be developed after hostilities begin. Standardization of equipment reduces training requirements and simplifies logistics. Quality control standards maintained under wartime pressure determine equipment reliability when lives depend on performance. These lessons shaped American defense policy throughout the Cold War and beyond. The principle that industrial capacity determines strategic capability became fundamental to American military planning. The success of programs like the M2A1 howitzer demonstrated that American industry could produce military equipment in quantities sufficient to equip not only American forces but also allied nations fighting common enemies. The story of the M2A1 howitzer is ultimately the story of American industrial transformation from peacetime production to wartime mobilization. The gun itself, 4,980 pounds of steel, precisely machined and carefully assembled, represents the application of American industrial capability to military purposes. The 8,536 howitzers produced represent the scaling of that capability to meet strategic requirements. But the true measure of success lies not in production statistics but in tactical effectiveness. American infantry commanders who could call for artillery support knowing it would arrive accurately and on time. American soldiers who advanced knowing that enemy positions had been neutralized by preparatory fires. American casualties reduced by the suppressive effect of overwhelming firepower applied consistently throughout the war. The M2A1 howitzer made these tactical advantages possible through the combination of sound engineering, quality production, and abundant supply. The gun's technical characteristics, range, accuracy, reliability, and destructive power provided the foundation for tactical effectiveness. The production program that delivered over 8,000 weapons provided the scale necessary for strategic impact. Margaret Kowalski's work at Rock Island Arsenal contributed to victory not through individual heroism but through collective industrial effort. Her expertise in howitzer assembly, multiplied by thousands of similar workers across American industry, produced the material superiority that determined the war's outcome. The precision of her work ensured that American artillery would function reliably when soldiers' lives depended on performance. The M2A1 howitzer program succeeded because it combined technical excellence with industrial capacity. Other nations produced artillery with comparable or superior technical characteristics. No other nation produced artillery in quantities sufficient to equip global military operations while maintaining consistent quality standards. This combination of quality and quantity became the foundation of American military power. As the war ended and production lines fell silent, the strategic implications of the M2A1 program became clear. The United States had demonstrated capability to design, produce, and deploy military equipment in quantities that overwhelmed enemy forces. This capability would shape international relations for decades as potential adversaries calculated their ability to match American industrial production in future conflicts. The 8,536 M2A1 howitzers produced during World War II represented more than weapons. They represented the transformation of American industry from peacetime production to wartime mobilization and back to peacetime capability. The skills, facilities, and organizational structures developed for howitzer production could be applied to other military requirements as strategic circumstances demanded. This industrial capability became America's most significant strategic advantage, more important than any individual weapon system or tactical innovation. The ability to produce military equipment in quantities sufficient to equip large forces for sustained operations provided options for military planners that were unavailable to nations with limited industrial capacity. The M2A1 howitzer, fired in anger for the last time during the Vietnam War, symbolizes the peak of American wartime production capability. The gun's long service life validates the engineering decisions made during its development. The weapon's widespread international use validates the production processes developed during its manufacture. The tactical effectiveness achieved by American forces equipped with M2A1 howitzers validates the strategic decision to prioritize material superiority over tactical innovation. In the end, the story of the M2A1 howitzer is the story of victory through industrial might. The gun itself was competent but not revolutionary. The production program was massive but not unprecedented. The combination of technical competence and industrial scale, applied consistently over 4 years of global warfare, proved decisive in determining strategic outcomes. Margaret Kowalski returned to peacetime work after the war, but her experience building howitzers influenced the rest of her career. The precision, attention to detail, and quality standards that characterized wartime production became permanent features of American industrial culture. The organizational methods developed for wartime mobilization provided templates for future defense programs. The M2A1 howitzer thus represents both the achievement of wartime production and the foundation for post-war industrial capability. The 8,536 guns produced during World War II equipped not only American forces but also the Allied nations whose cooperation became essential for post-war security. The industrial capacity demonstrated by the howitzer program provided the foundation for American leadership in the technology-intensive conflicts that followed. The legacy extends beyond military applications. The manufacturing techniques, quality control processes, and organizational methods developed for M2A1 production influenced American industry throughout the post-war period. The precision machining required for artillery manufacture contributed to advances in automotive production, aerospace engineering, and electronics manufacturing. The workforce training programs developed to produce skilled artillery workers provided models for industrial education that shaped American technical training for generations. Margaret Kowalski's expertise, developed through wartime production requirements, became part of the human capital that drove American industrial development through the remainder of the 20th century. The strategic implications continue to influence American defense policy. The principle that industrial capacity determines military capability remains fundamental to defense planning. The success of the M2A1 program demonstrates that sustained investment in production capability provides strategic options that cannot be developed during wartime emergencies. But perhaps the most important legacy of the M2A1 howitzer lies in the demonstration that democratic societies can mobilize industrial resources for military purposes without sacrificing the values that make mobilization worthwhile. The workers who built these weapons maintained civilian control over military production while achieving performance standards that exceeded those of authoritarian competitors. Margaret Kowalski and her colleagues proved that free societies could outproduce totalitarian states while maintaining the individual freedoms and democratic institutions that made victory meaningful. The M2A1 howitzer, produced by American workers under American management for American strategic purposes, represents the successful application of democratic values to military requirements. The 8,536 howitzers stand as monuments to this achievement, not just as weapons that helped win a war, but as products of a society that could mobilize its industrial capacity without abandoning its fundamental character. The precision of their manufacture reflects the skill of American workers. The scale of their production reflects the capacity of American industry. The effectiveness of their employment reflects the competence of American military leadership. Together, these factors created strategic advantages that proved decisive in the largest conflict in human history. The M2A1 howitzer, humble in appearance but devastating in application, symbolizes the transformation of American industrial capacity into military power sufficient to reshape the global balance. The story of its production is the story of democracy triumphant through industrial might applied with moral purpose. In the final accounting, the M2A1 howitzer succeeded not because it was the best artillery piece in the world, but because it was good enough to be produced in quantities sufficient to equip American forces and their allies for victory. This combination of competence and capacity became the foundation of American military power and remains relevant for strategic planning in an uncertain world. The lessons learned from Margaret Kowalski's work on the Rock Island Arsenal production line continue to inform American defense policy decades after the last M2A1 howitzer fired its final round. The principle that industrial capacity must be developed during peacetime to be available during wartime remains valid. The importance of maintaining quality standards under production pressure remains crucial. The value of investing in worker training and equipment modernization remains essential. The M2A1 howitzer program thus provides both historical example and contemporary guidance for maintaining the industrial base necessary to support American security interests. The 8,536 guns produced represent not just past achievement but continuing commitment to the principle that peace is preserved through strength, and strength depends ultimately on the capacity to produce the tools necessary for defense. As we consider contemporary security challenges and the industrial capacity required to meet them, the story of the M2A1 howitzer reminds us that strategic success depends on combining technical competence with production capacity, individual skill with collective effort, and immediate tactical requirements with long-term strategic goals. Margaret Kowalski's precision in assembling howitzers contributed to victory because it was multiplied by the precision of thousands of similar workers and supported by industrial systems capable of sustaining production under wartime conditions. The M2A1 howitzer thus stands as both weapon and symbol, a specific tool that helped win a particular war, and a representation of the industrial capability that remains essential for maintaining peace in a dangerous world. Its story reminds us that freedom must be defended, defense requires strength, and strength depends ultimately on the capacity to produce the tools necessary for security. The 8,536 howitzers produced at Rock Island Arsenal and delivered to battlefields around the world represent democracy's answer to the challenge of totalitarian aggression. Their production demonstrates that free societies can mobilize resources for defense while maintaining the values that make defense necessary. Their effectiveness in combat validates the strategic principle that sufficient industrial capacity, properly applied, can overcome tactical disadvantages and achieve decisive results. In the end, the story of the M2A1 howitzer is the story of America in World War II, a nation that transformed itself from peaceful production to military mobilization, achieved victory through industrial might, and returned to peaceful purposes while maintaining the capacity to defend freedom when threatened. The precision of Margaret Kowalski's work symbolizes the precision of this transformation. The effectiveness of the weapons she built symbolizes the effectiveness of American strategy. The legacy continues in contemporary defense programs that apply the same principles of technical excellence and industrial capacity to meet current threats. The M2A1 howitzer, long since retired from American service but still remembered for its contribution to victory, reminds us that strategic success depends on combining individual skill with collective effort, present capability with future requirements, and tactical effectiveness with strategic purpose. The 8,536 howitzers stand as testimony to what free peoples can accomplish when their security is threatened and their values are at stake. They remind us that the price of freedom is eternal vigilance, and vigilance requires maintaining the industrial capacity to produce the tools necessary for defense. Margaret Kowalski's work building howitzers contributed to victory because it represented the commitment of an entire nation to the principle that freedom is worth defending and capable of defense when properly supported. The story continues as new challenges require new responses, but the fundamental lesson remains constant. Security depends on strength, strength depends on capability, and capability depends on the industrial capacity to produce the tools necessary for defense. The M2A1 howitzer, produced in quantities that seemed impossible until they became necessary, demonstrates that democracy can meet the challenges that threaten it when free peoples unite in common purpose and apply their collective capabilities to common defense. The last M2A1 howitzer manufactured at Rock Island Arsenal, serial number 8536, rolled off the production line on August 14, 1945, the same day Japan announced its surrender. Margaret Kowalski, now Senior Quality Control Inspector, performed the final acceptance testing on this weapon, unaware that she was closing a chapter in American military-industrial history. That howitzer would serve with the 82nd Airborne Division during occupation duty in Europe, fire supporting rounds during the Korean conflict, and eventually find its way to the Aberdeen Proving Ground Museum, where visitors can examine the precision of its manufacture and contemplate the industrial achievement it represents. The placard beside the gun records its basic specifications but cannot convey the full story of the 8,536 similar weapons that armed democracy for its greatest trial. In quiet moments at the museum, when visitors pause to examine the gun's simple but effective mechanism, the ghost of Margaret Kowalski's precision lives on in every carefully machined component, every properly torqued bolt, every specification met despite the pressure of wartime production. The howitzer stands not just as a weapon, but as a monument to the principle that free peoples, properly organized and sufficiently determined, can produce the tools necessary to defend their freedom. The thunder of 8,536 howitzers, fired in anger across 6 continents and 4 years of global warfare, echoes still in the strategic calculations of nations that contemplate aggression against free peoples. The industrial capacity that produced those weapons in quantities that seemed impossible before they became necessary continues to underwrite the peace they helped secure. Margaret Kowalski's work, multiplied 8,536 times, helped change the world. The precision of her craftsmanship, replicated across American industry, created the material foundation for victory in humanity's greatest conflict. The story of her contribution reminds us that strategic success depends ultimately on the accumulation of individual excellence in service of collective purpose. The M2A1 howitzer, born from the marriage of technical competence and industrial capacity, proved that democracy could outproduce its enemies while maintaining the values that made victory meaningful. Its legacy continues in the principle that peace depends on strength, strength depends on capability, and capability depends on maintaining the industrial capacity to defend freedom when freedom is threatened. In the end, 8,536 howitzers changed history not through individual brilliance but through collective excellence, the excellence of workers like Margaret Kowalski who understood that their precision mattered, their quality standards mattered, and their contribution to the common defense mattered more than personal comfort or convenience. The thunder of those guns has faded, but their legacy endures in the understanding that free peoples, united in purpose and supported by industrial capacity, can overcome any challenge that threatens their survival. The story of the M2A1 howitzer is ultimately the story of democracy triumphant not through superior ideology alone, but through the practical application of democratic values to the requirements of defense. As long as freedom requires defense, the example of the M2A1 howitzer program remains relevant. Technical excellence combined with industrial capacity, individual precision multiplied by collective effort, and immediate requirements balanced against long-term strategic goals. Margaret Kowalski's work building howitzers contributed to victory because it embodied these principles and demonstrated their continuing relevance for maintaining peace through strength. The 8,536 howitzers thus represent more than weapons, they represent the enduring capacity of free peoples to defend their freedom when properly organized, sufficiently determined, and supported by industrial systems capable of producing the tools necessary for victory. Their story reminds us that the price of freedom is eternal vigilance, and vigilance requires maintaining the capability to meet challenges not yet imagined with tools not yet invented but built according to principles proven by history. The thunder continues, not in the roar of guns but in the quiet hum of production lines maintained against future need, in the precision of workers who understand that their craftsmanship matters, and in the commitment of free peoples to maintain the capacity to defend the values that make their freedom worth defending. Margaret Kowalski's legacy lives on in every American who understands that security depends on strength, strength depends on capability, and capability depends on maintaining the industrial foundation necessary to meet whatever challenges the future may bring. The M2A1 howitzer, instrument of victory and symbol of democratic industrial power, stands as eternal reminder that freedom defended is freedom preserved, and freedom preserved requires the continued commitment of free peoples to maintain the capacity to defend what they value most. The story of 8,536 howitzers is ultimately the story of democracy itself, challenged by enemies, tested by war, and proven capable of whatever sacrifice victory requires. In the thunder of those guns, future generations can hear the sound of freedom defended and democracy preserved. In the precision of their manufacture, they can see the standard of excellence required for success. In the scale of their production, they can understand the commitment necessary to overcome challenges that threaten the survival of free institutions. The legacy endures, carried forward by each new generation that accepts responsibility for defending freedom and maintaining the capacity to meet that responsibility when history demands it. The story of Margaret Kowalski and the M2A1 howitzer reminds us that this responsibility belongs not to governments alone but to all free peoples who understand that their individual contributions matter and their collective effort determines whether freedom survives. The 8,536 howitzers stand as testimony to what free peoples can accomplish when their survival is threatened and their values are at stake. Their story continues in every American who understands that the price of freedom is vigilance, vigilance requires strength, and strength depends on maintaining the industrial capacity to defend freedom when freedom is threatened. The thunder fades, but the lesson endures. Democracy, properly supported and sufficiently determined, can overcome any challenge that threatens its survival. The M2A1 howitzer, product of American workers and symbol of American industrial might, proves that principle and provides guidance for meeting whatever challenges the future may bring.